And we are live. We are live. Amazing. You can also see it. I'm just double checking. You can also see it on our X profile. You can also watch this video on YouTube. Yeah, Christian, we're just going to wait for a few seconds and then we're going to start until we get some people in. It just went out on X. So yeah, a few seconds and then we start.
Awesome.
Okay. Hello, everyone. Can you hear me? Can you hear me, Christian? Yeah. Okay. Amazing. You just muted yourself.
Yes.
Yeah. Hello, everyone. Nice to see you again on our Thursday's live stream. We're trying to make this a habit, so you will see us every Thursday, especially me, since I'm most certainly going to be the moderator for these sessions. And yeah, for today's session, we have coding AI-powered dApps with GenLayer. And we also have today with us Christian. Christian is our head of developer experience, working for Jaeger AI, the foundation behind GenLayer. And we're going to look into coding intelligent contracts. How do we make use of our AI on chain, our consensus mechanism, and we're going to look at which fancy things we are going to code. My name is Tony. I'm the head of content and community for GenLayer. And just to mention at the end of this walkthrough of this demo, we are also going to share a POAP link where every one of you can mint a POAP. For that, you will need the POAP Home app. I'm going to drop the comment in the descriptions. And yeah, if there's any question before Christian starts coding, feel free to drop them in the comments as well. We're happy to answer all of those. If you need help, like with your own walkthrough of intelligent contracts, feel free to ask those questions as well. Christian is happy to help you. And yeah, without further ado, I would say, Christian, maybe you can tell us what we are going to look at today. I mean, I know it, you know it, but the people don't. So maybe you can introduce the topic shortly and explain what we're going to do.
Yeah, of course, Tony. So we are going to develop an intelligent contract on GenLayer, where we are going to use special and unique features of GenLayer. We're going to request web data, and we are going to send LLM prompts with that data to get some results and conclusions and to resolve a prediction market. In this case, we are going to develop an intelligent contract that is going to allow us to bet on some sports, all right, and earn some points based on that. Okay? In this example, it would be all up to that. Of course, you can continue with us and looking more advanced examples in the future. Right now, we're going to earn some points, but that could be easily scale up until have ERC20 token distribution or whatever.
So prediction market. Some of you may already know that GenLayer is powering a few prediction markets already. We have some partners that we're doing that with. And yeah, maybe before you start, Christian, I'm just going to add your screen to the stage. I see that you already started screen sharing, so you can prepare. Just to give you a scope of how prediction markets. Some of you may know that prediction markets completely took off last year, especially with Polymarket. Resulted in huge volumes. We had one of the highest volumes in November 2024, with going into the presidential election in the US. And there's been a lot of buzz around prediction markets. And the funny thing is, though, that the biggest prediction market, Polymarket, is still using more or less humans to resolve markets, which is very costly, takes a long time, and is prone to errors. And if you just compare it, you can resolve prediction markets within a few minutes, up to an hour, let's say, instead of the current process that we have, which takes up to 3 days. And that's what Christian is going to show us now, how to code that. And maybe, Christian, you can also give a short introduction to the studio in general, and then start demoing, coding the intelligent contract for the prediction market.
Of course. Yeah, for the ones that doesn't know the studio, this is our platform. Is a web browser-based environment to code intelligent contracts. Here you can actually have some examples. You can play with them. You can create your own, and from here you can also go and run your contracts, debug them, and interact with them, calling their methods and everything. Here you can also see the validators that are already working in this version of the studio, right? And all of this is hosted at studio.genlayer.com. You can just visit there and use this tool, or you can also clone the repo, which is open source on GitHub, and actually run it on your own machine, where you can actually run your own validators, and you can choose which models and which providers you want to use.
A few of them: GPT, Claude, Mistral, Llama, DeepSeek, I think, since 2 weeks, right?
Yes, already out of the box, you can use any of them. Or if you want to include something different, if it's compatible with OpenAI API, it's really straightforward. If it's not, you can develop your own sort of plugin, so it can be used by the GenVM as the execution environment. Okay.
Cool.
Okay. Should we start now?
Let's go.
Okay, let's go. So this intelligent contract, as I said previously, is going to consist on some bets on predictions about football games. Okay, so let's start by creating a new contract here. I'm going to call it football bets. Okay, the first thing that I have to do, we can just ignore the errors right now. This means that the studio is sending our code to the GenVM to validate the code, but right now, of course, it's an empty file. It doesn't have anything, so it's normal that we have some errors, and until we have like a initial template on how our intelligent contract is going to look like, we can just ignore these errors. Okay, so the first thing that I'm going to do is to add the comment of the version. In this case, I'm using the GenVM test version. This is going to evolve with time, and here you will be able actually to choose which version of the GenVM you want to use for your intelligent contract, very similar to what you do with Solidity Smart Contracts. Okay, so from here I'm going to import the GenLayer SDK to be able to use all the features of GenLayer, right? So I'm going to import everything from here, and I'm also going to import the data class from Python, so I can give a little bit more structure to my data, okay, and to my state, to my contract state. So right now, let's try to think how a bet is going to look like, okay, and let's model that with a data class decorator, so we can actually structure our data in that sense. Okay, so a bet, we can think of a bet something that a user is going to create, right? And when the time comes, they are going to resolve that bet, okay? And the resolution of that bet is going to consist on getting some data from a website, inserting the data into an LLM prompt and ask the LLM the outcome of that bet. Okay, so we need to structure all the data in what's going to be our contract state. Okay, so let's set an ID, because maybe we don't want players to create multiple bets on the same stuff. So let's try to sort them and to create an ID, which also could be useful whenever we want to resolve a given bet. Okay, so an ID is going to be just a string. Okay, what else? We can also have a flag, something like has resolved, so we can actually mark, right, this bet as resolved or not resolved. Let's also set a date for the football game that we are going to bet on, right? Let's set up a resolution URL, also as a string, right? Then let's have both teams, team 1 and team 2. As I said, let's ignore the errors for now. Of course, this is not a valid intelligent contract, and that's why the GMBN is complaining, okay? So now, as a user, if I want to bet on this football match between these two teams, I will probably also want to predict a winner, right? So a predicted winner is going to be one of them, one of the two teams, right? And we can also, for the sake of the information, to have everything that we would need, we can also include some more information here about the bet, like what was the real winner, right?
And Christian, one question: what do you do if the bet can't be resolved to yes or no? What happens?
In that case, we will choose in the code as well what we are going to decide to do. In that case, probably we can ignore and let the user resolve it again after, like a try again. Yeah. Or we could just flag the bet as an error and don't allow the players to resolve it again. It's up
but
to
then,
us.
okay, so it's up to us if they can resolve it later. So let's say someone initiates the resolution and it's not yet like fake, the outcome is still pending. We don't know, right? Then it would be able to either say, okay, let's remove it completely. That's it. That was your chance. You missed it. Or we say, okay, you can initiate how often you want later on.
Exactly. In that case, it's up to us as developers to choose the logic for our contract.
Yeah. Okay. Cool.
Okay.
Thanks.
So let's also record the real score, right? So maybe we can extend our bets to not only bet on the team but also on the score, whatever we want, right? So this more or less seems like a good data structure for a bet. Now let's start with what is actually the contract, right? We need to add this decorator as a GenLayer contract. And by the way, if you're using this version on studio.genlayer.com, this is the way that you create intelligent contracts, and that's going to evolve very soon. And mostly these decorators and how you declare your class for intelligent contract is going to change slightly, but we will be sure to announce that properly and to provide you some examples so you can know how to migrate your contracts. Okay, so now let's create our contract, right? And whatever is our state, our contract state that we want to persist between transactions, we need to declare them as a class variables as well. So in this case, we are going to have the bets, which is going to be a mapping, right? Or the way that I'm looking at it is going to be a mapping between the users' addresses, right? That's a very common practice when you do smart contracts on Ethereum, for example. That way you can be sure that this user was the one that created that entity, that bet, and the bet object, right? So in this case, we will have a tree map. If you know already, it's the way how we define the maps in GenLayer, right? And here, what are we going to map? We're going to map addresses. All right. And here we could put just a bet if we would like just to have one bet per player. But in this case, let's go a little bit further and let's allow multiple bets per user. Okay. So one address is going to map to another map, right, of a map ID, probably, right, that string, and a bet. So in this case, this can seem like a user address, right, that has many, right, like in a map, an ID and its bet, right, let's say ID 1 and bet 1, and we also can have ID 2, bet 2, and so on. Okay, this is how this looks a little bit. And this would be, for example, the user address 1. And at the same time, we can have user address 2, which will map to their own bet. So every user can bet on their own games. Two users can bet on the same game, but like in their own bet, at least on this logic. Of course, we could implement the approach that we would like, okay? What else? So let's have also our constructor, right? So we can, in this case, since we really don't have anything, we can just pass because we don't need to make any initialization of that structure. Okay. Okay. Let's see what's in that errors, right? What is it about? It says that in line 1 and line 4, this import data class not found. Maybe I missed something, but the classes probably, yes, is. Okay, let's see if the error goes away. We could also inspect the error here, right, in the contract schema code, right? Let me scroll down to the end of it. And we can see that here we had the same error. We can use this to debug a little bit the behavior of our contract, right? Here we will be able to see what was actually happening. Okay.
This was Christian, we have one question.
Of course.
So Freaks is asking, do these intelligence contracts need to be coded in a certain language like Solidity or Rust, or are they language agnostic? Maybe you can share a little bit about a Python-based SDK so people understand how many possibilities this actually opens for developers that are not native to Solidity or Rust.
Exactly. Yes. As you may know, Python is one of the most used programming languages in the world. And that's why we choose to have Python as the base of to code intelligent contracts, right? So what we have added here, it's our own SDK, which gets bundled with the code of your intelligent contract and gets executed in the GenVM, right? So in that case, you can use all these features that we provide in the GenLayer SDK, but it's just plain Python. Of course, that I mean, it's an open source project, right? Anyone could come with another execution environment in Rust or in any other language and allow people to code the intelligent contracts on the language that they want.
Yeah. Right. So anyone can check it on GitHub, Jaeger AI. We have the full code open source. You can do whatever you want with it. You can print it out, hang it on your wall. Yeah.
Of course.
Like Christian did, like everywhere in his flat, he just has GenLayer code printed out on the walls.
Exactly. It takes like many rooms, but it's all the rooms are completely with the papers on the walls.
Like in prison cells.
All right. Let's start adding some view method. At this point, we cannot create any data, but we can start trying to deploy our intelligent contract and see how it goes, right? Of course, it's always like a better approach to start deploying and test it step by step than waiting for the full implementation to be ready to start debugging, right? So let's try to go step by step and let's code our first view method that is going to return these bets, okay? So for that, we need to add the decorator that allows to declare a method as a public view. Okay, so gl.public.view. Okay, and here we are going to call it get bets. Okay, in this case, it's just getting self, and it's going to return a dictionary of all the bets. Okay, and in this case, in a very Pythonic way, we are going to return, right, a dictionary of all the bets, which is going to be, in this case, we know that the bets are address maps to this also map of bet ID and bet. So let's, for returning the address in a proper format, we need to return this address as an hexadecimal string. So it will be, as you know, usually, right, you do key K and V for all the items on a key value structure. So we do key as X is going to match V, right, for K and V in self.bets.items. Okay, let's see if the error goes away. This is sending our code every time to the JVM just to check that it is proper written, that is free of syntactic and static errors, right? Syntax errors and static errors. And we will soon add more features to the studio to let you know exactly where the error is and a little bit more information. We are evolving the studio every day, so you will get those. So right now we can deploy our intelligent contract, right, and see what happens if we call this method, which in this case is going to return like an empty map, right? So for that, let's go to the run and debug section on our studio, right? There are non-constructor inputs. If we had any, they will appear here. But in this case, there are none, so we can just deploy our intelligent contract. Okay. So this is going to send a transaction that is getting executed by the JVM, running the whole consensus algorithm in our studio backend, right? So in this case, we saw the transaction went through all the steps, it was just to deploy, and we can see here that our contract got deployed in this address, which is the same address that we can see right here, which is the address of our intelligent contract deployed in the studio. This was the code that we sent, and we can see a bit of the consensus process here. Okay, so execution was a success. That means that the contract got deployed, its constructor was called and executed properly, and all the validators agree on the result. So it got to the final state where it got deployed, right? We could also inspect a little bit more on the full transaction data, and if we happen to have some non-deterministic code, such as getting web data or calling an LLM, we will be able to see those right here, okay? So, yeah. Tony.
Thanks for the explanation, Christian. We have one more question from Batan. Are there situations in which intelligent contracts cannot access real-time data, for example, natural disasters or power outages? That's a very good question. What do you say?
I'm not sure if I can follow up on this question. If they cannot access, they can access any web URL that you can give it. So it's going to fetch the content of that URL. So I'm not sure about if I got it correctly.
Maybe I can answer it. I think I know where he's going. So there's two sides to this. You can always fetch data from the internet if there is a natural disaster, let's say, because someone is gonna, you can use a news website, you can use the natural disaster website of the national weather forecast, whatever. So there's always going to be someone reporting on that. You just need, let's say, a website to put that information online, right? That's the only requirement, basically. So yeah, and the good thing about the second thing, which I'm not sure he was going to, but I think there is a part to it where anyone who uploads the data on the website, on the internet, the intelligent contract can fetch it afterwards, like regardless of the natural disaster in that particular region. Maybe that's where the question was headed.
Yeah.
If not, Vatan, please feel free to clarify in the comments.
Please, yes. Every time that we talk about this, getting the web page or like a website content, people ask like, okay, how can I really trust that you are fetching the data from a trusted source? And in this case, for example, where we are going to set the URL where we are going to fetch all the data. So if our contract code is public, anyone could actually look for it, and they can validate where we are, or like what website we are trusting to get the result of these bets.
Yeah.
So you can choose.
Okay, we have one more question, but I would kindly, thanks for the question, Freaks. He's asking about the ZK Sync integration, and I would propose let's wait until we have the validator results, and then we can maybe explain how the ZK integration works and how the validators and why our consensus mechanism needs ZK Sync. I think that's,
of course.
Yeah. So sorry, Sheiks, we're just gonna let Christian continue, and then we're gonna answer your question.
Sure. So our contract got deployed, and then we can execute its methods. Those in the studio, they are separated. We have the read method and the write method, which we don't have any right now, right? So let's call the getBets and see what it does. All right. So in this case, it's going an empty dictionary because there are none, right? Okay. So now, what if we let's create our first bet, right? So let's code the method that we need, right, to create the bet. Okay. So let's create it as, in this case, it's going to be yel.public.write. Okay. And let's call it create bet. In this case, we want the user to give us, for example, right, the game date, the teams, and the predicted winner. We can calculate the rest of the data that we have for the bet right here. Okay, so let's in this method, whenever you want to execute it, let's ask for the game date as a string, the team 1 as a string, team 2 also as a string, and the predicted winner as string as well. Okay, so, and in this case, this method is not going to return anything, and we can start right here. Okay, so let's make a small parenthesis to explain how are we going to fetch the data, right? So in this case, what we are going to do is to call the BBC Sports website, right? And I'm going to use, let me share this tab. How does it look like, right? So I'm gonna, we're going to look for this website and to look for a match that should have been finished, right? And get the score and let the LM to decide who won the game and give us the outcome. Okay. So in this case, for the sake of the example, let's choose some game that was already finished, right? Because if we choose something that is not yet finished, the LLM will not be able to give us a proper response. Okay, so we can use, for example, this game, Australia and Colombia, right? So let's set the resolution URL of our method to this bbc.com sports website, which of course you are not looking at the URL right now, but the way it looks, it's with the date at the top. Okay, so I'm going to paste like an example URL here. This is how it looks, right? So we can just add the game date that the user used to call this method to get the resolution URL. Okay, so let's create what's going to be the match resolution URL, which is going to be this, right? So if the user gives us the game date, so it's going to be game date in this case. Okay, so we can come with a full URL that we can query, we can fetch all its content and get the resolution, at least the results of the current games. Okay, so in this case right here, what I would do also is to, based on the game date, probably decide if the match that you want to create a bet on is already in the future, right? Because it would be like very unfair to create bets on matches that was already ended days before. But for the sake of the example, let's keep it. Let's keep this check so we can validate how it works. Okay, we can add it later. Okay, we can add like a comment here to remember to check that in the future, right? Check that the game date is in the future, and we could raise an exception and stop its execution, right? Okay. Also, this we need to get the user that is calling this method to create the bets on their piece of the state, right? We said that the first thing that we're going to have in the bets is the user address and then all their bets. So to do that in GenLayer, you do something very similar to what you do, for example, in Ethereum, right? So the sender address is going to be, you use the SDK again, gl.message, right?
Christian, we can't see your demo screen, the studio screen. Sorry.
I'm sorry.
Yeah, now we
Thank
see
you
it
for
again.
letting me know. Okay, let me recap a bit because you lose a bit.
Correct. Just highlight. Yeah, correct. Just highlight what you've been. Yeah.
Exactly. So here we have the match resolution URL, right? That I pasted from the one that you were looking at the BBC Sports website. And here we add the game date because this is how it looks like, right? All the results for a given date in this website. I also added here the check that we need to remember to add in the future to ensure that we are not creating bets of games that were in the past, right? And right now I'm getting from the GenLayer SDK the user's address, okay? In this case, is the sender account. This is one of the things that is going to change very soon to sender address, okay? But in this case, this is a safe way to get the user that is invoking our method, because that means that was a user that was able to sign the whole transaction with that address, okay? And now let's create the bet ID, right? How we can create this. Let's say that we can have the date and also the teams. And with that, we can assemble like a unique ID for a bet, okay? So in this case, we can set that is game date, right? We could also add here team 1 and team 2, okay? Let's avoid any mistakes for users calling with different formats. Let's make everything lowercase, and now we have our bet ID, okay? For example, we could also perform some checks here to ensure that the user is not creating a bet that was already created in the past, right? So we can see how we can revert the execution of some methods and to actually stop the execution if we think that is not the way that we want to proceed, okay? So in this case, let's say if the sender address in self.bets and the bet ID that we just created is in self.bets at the sender address, right? In this case, we would like to raise an exception, right? And say, for example, the bet was already created, okay? And we stop the execution, right? We can stop for a bit and see that everything is fine. There are no errors in our contract, and we can continue, okay? In this case, let's assemble what is going to be the bet object, right? So the bet is going to be a bet that we are going to create here, okay? So we have the ID, which is the bet ID that we just created, right? We have to initialize the has result flag as false, right? We also can set the game date as a game date already provided, right? The resolution URL, let's initialize that with a match resolution URL that we just created as well. I skip that comma. Okay, let's add the two teams. Sorry, team 1, team 2, and what was the predicted winner, right? That the user sent us right there. We can also initialize what is going to be the winner underscore, the real winner underscore, so as an empty string. Real winner, it's an empty string, and real score as an empty string, okay? So now that we have our bet created, we can just add it to the tree map, right? That we have right there on the bets, right? So let's do self.bets, and here we can use that method on the tree map is get or insert default, right? Add the sender address bet ID, right? That is the place where we want to add it. We can add the bet, okay? And this would be ready just to try right now and see if we can create the bets and get the response. Okay, so let's deploy a new instance right now, because the previous one that we deployed didn't have all these methods. Okay, let's see how it goes. So the transaction is going through the consensus, right? And whenever it's accepted, we can start trying.
I'm just going to add here for those who joined later. So Christian is coding a prediction market, a football prediction market on a certain game and score. And basically, it shows you how GenLayer works, fetches data from the internet natively with our intelligent contracts that you can code on a Python-based SDK. And you can basically do that with any information from the internet. There was a question before. You can do that on, did it rain today? Did it, what's the weather forecast for tomorrow? What's happening around the world? But basically anything you can set your imagination to. And right now, Christian just finished coding and is creating the bet, deploying the intelligent contract. And now he's going to show us, how it looks like and how to proceed.
Of course. So right now, we can see that the new write method is added right here, right? Which we didn't have before. If we call the bets, there are none. But now I can create, right, one bet. So we saw in the BBC Sports website that it was Australia against Colombia earlier today that was already resolved. We can use that for the example, right? So the day would be today, right? We have Australia and Colombia, and let's say that the predicted winner, if I can see the outcome, it was the team 2, right? Team 2, Colombia. I can send this transaction right now, and this is going to create the bet, okay? And now we are going to call the get bets as soon as this is in accepted state, and we can see our bet here created, okay? Maybe it was too soon. Let's try to create another one for the second match that we just saw. It was United States against Japan. And then if that's done work, we can also, let's put the same team, because in this case was United States or Japan, the one, okay? And if not, we can try to debug what happened if there is any problem there. I don't see it. Okay, let's call the bets and see what do we have. Oh, there is none. Let's see what we have right here in our bets, right? So maybe there is some error. So it's something that is not coming out, right? We have the get bets method. Okay, we can see that there is some problems right here, right? So let's debug to see if maybe there was some problem when we were executing the create bet method and see what did it come, right? We can also go here and see that the create bet did return an error. So that doesn't mean that the finalized status is wrong. The transaction execution resulted in an error, right? And that error was validated by all the validators. So they all agree that the execution was returning an error, and that's a proper transaction that got accepted and finalized. That's why we are not seeing any bets. So let's see right here in the logs, we can see what happened, right? So let's see in the code what could have happened. Okay, so we can see that the tree map, okay, doesn't have this method get or indert default, because I misspelled that and I just coded wrong. Okay, so I'm gonna fix my method. I'm gonna fix it to what it should be. Right, I'm going to deploy a new instance, and now we're going to create the bets and see if that goes fine. I'm going to clear the logs here, right? And just for make the debug easier, I'm going to set only the errors, okay? Just to see if there are any errors right here. I'm going to use the same date, and it was Australia against Colombia, and I predicted that the winner was the team 2, we said, okay? So let's see the transaction, right? We could also filter by the component of the execution flow that we want to see the outputs, right? We could only see MVN logs, only the RPC server logs, or the consensus. It seems like there is no error right now. We can just remove the filter, and it seems like the execution was just fine. Okay? We can also see here that right now we have that success, all right? And that would mean that if we query all the bets, we will probably get all the results here, okay? So we see that from my address, which we can also here right in the top right corner, right? This is the address that I'm using to interact with my contract. This user has created this bet, right, with this ID. Remember that we said the bet ID was the date and 2 teams, right? And this is the object of the bet. The date was today, has result is false right now, right? The ID of the bet is right here as well. The predicted winner by the user was the team 2. There is no real score, there is no real winner, and here we can see the resolution URL and the 2 teams that are part of that match, okay? So right now we need, right, a resolution for that bet. So let's code the method that we're gonna use to resolve that bet and decide if the user was right or not, okay? So a resolve bet would be also a write method, right? That we need to declare in the same way with the decorator gl.public.write, right? And let's call it resolve bet. This should receive probably will be enough with the bet ID, right? Because with the bet ID, we can actually get the bet from the user, right? So let's ask for the user to give us the bet ID. Okay, and it's going to return none in this case. I'm not sure, Tony, what time do we have left? Just for the sake of the demo, not to make it too long.
Yeah. I mean, basically, we have another 5 to 10 minutes. I don't know if we can. I would just like to take a minute to show the intelligent oracle that is already up and running.
Okay, let me speed up a bit. Okay, let's get the bet from the tree map that we already have, right? That would be self.bets. Let's try not to code it wrong, because then we will lose more time. Okay, let's get the message sender, right? And the bet ID the user has given to us, okay? Okay, let's try to skip some validations and just execute the things that we want, right? To resolve the bet. Okay, so first thing that we're gonna do, let's code a function here inside this method that is going to be responsible to execute all the non-deterministic part of our code. That's going to be to get the content of the website, the resolution URL that we have set on our bed, right? And to send all of that to the LLM so we can get the response. So let's call it get match result, right? This is not going to take anything as input parameters, right? And it's going to produce a string, okay? So in this case, the first thing that we need to do, right, is to get the web page content, right? That's going to be using the GenLayer SDK, get web page, right? Let's add the bed.resolution URL, right? And here we can ask for two modes, text or HTML, right? I'm going to ask it only on text because I don't want to look for the HTML code, and actually the text is more efficient because it's less code, okay? So in this case, that would mean that in this variable, we have all the web data of that page, right? And now I'm going to, for the sake of the time, I'm going to take the prompt that I have already crafted before, so I can call the LLM with all that data, and we are going to walk through it, okay? So in this case, I'm going to call it task because it's a task that I want to ask for the LLM. So I'm declaring, right, that maybe for the example, let's put here all the variables that we need right there. So it's going to be the resolution URL is the bed.resolution URL. The team1 is the bed.team1. So sorry, and team2 is the bed.team2. Okay, so that would make things easier, and also because the non-deterministic code needs to have all the variables in the nearest scope. So we're going to set to the LLM that we have a match between these two teams, right? Team 1 and team 2, and that the web content is right here, and that we want a response in JSON format with the score, right? In this case would be like, for example, 1, 2, or just a dash if the game is unresolved, right? And the winner, which is going to be the number of the team, if it's 1 or 2, 0 if the game resulted in a draw, or -1 if it's unresolved, right? I'm adding here some helper text to the LLM so we can be sure that it returns something that is easily parsable as a JSON, and we don't fail in the execution just because of the format of the answer, right? So right now, the result is I'm going to use, again, the SDK to get this task resolved by the LLM, right? So with the GenLayer SDK, I call the exec prompt sending this task. And here, just in case the LLM responds with some formatting or some extra content that I don't want, right? That this should be parsable as a JSON. I'm going to say that I want to replace whatever formatting it gave us with at least to remove them, right?
I'm not
think
sure. Yeah, now you're back.
Okay.
No
So
rush.
in this case,
Now you're
right,
back.
this is, no?
Yeah, now you're back. All fine, all good.
In this case now, I can just return, right, JSON dumps of JSON to a dictionary, okay, of the result, right? I can send, for example, sort keys parameter as true, so I'm sure that gets sorted. And I cannot forget to import also JSON library, okay? So in this case, we have this method, right, that has my non-deterministic code, which gets the web data, passes to the LLM, executes this prompt with the web data included in that prompt, right? I execute that prompt. I try to remove any formatting stuff that the LLM may add on its answer, and I parse it and convert it as a JSON object, okay? So right now, before closing my method, right, what I need to do is to get the output of that non-deterministic code, right? So my result JSON is going to be executing that non-deterministic code, right? Which I also need to do with the GenLayer SDK, right? With the equivalence principle function, right? My equivalence principle, and I want in this case to be strictly comparative, right? To every validator to execute the same, and to every validator to validate that whatever the leader says, it's they agree with that, okay? And here I just need to pass my piece of code, okay? So right now I have my result, right? And here, after I do this, if the match should be resolved. Let's say check for that, right? I want to convert whatever the status says as the winner, right? So my result JSON winner, right? I want to convert it as a string, and if it's less than 0, that means that the game is not resolved. In this case, I cannot process the bet anymore because the game is not finished, right? Wait, sorry. Exception. And we can say game not finished, okay? Right now, we can say that the game has a winner, right, or a draw. So I can set my bet object, right, that I got from my tree map right there at the beginning of this method, right? Let's set the has resolved as true, right? We can also set the real winner as let's convert to a string whatever they tell us here, but because sometimes it can get with different format or data format, right? And the real score as the result JSON score, right? And that would be it. Okay, in this case, we are just writing on the state, and the bet should be updated, okay? So I am, again, deploying the intelligent contract. Let's see if this ends in success. That's great. Now we can create the bet that we previously created again, right? Because there is a new deployment, so it is not with the same state that before. Okay, Australia against Colombia, and the game was today. Let's send this transaction. Then we are going to, let me scroll down because we're getting confused here with too many logs. Maybe we can just clear it and get the same again. Execution was a success, right? And when we get the bets, we're going to get in the previous state, right? And I can copy my ID, right? And see, remember here, real score none, real winner none, right? And I can call the result bet, which hopefully gets resolved properly. Okay, let's see if the execution turns out to be fine. Let's inspect here the equivalence principle outputs. And what was the question before, Tony, that we needed to answer now?
Yeah, I wanted to show this with the window you had open with the transactions with the validators. On the left bottom when you click on transactions. So the question was, I'm going to read it out loud. Can you explain the ZK Sync integration in simple language, please? From what I know, ZK Sync is a layer 2 chain on Ethereum, and you guys are building your own layer 1 blockchain. So I don't quite understand how this integration works. Sorry, I'm not a coder. All good, Shrieks. That's why we're here for. Thank you for the question. And indeed, it is a very good question. And it took me a long time to understand it from this guy that is sitting in front of me, basically, not across, because you're not here. So the thing is, we don't like to call ourselves a layer one blockchain. We like to call ourselves a new kind of, distributed ledger technology, a new kind of blockchain, let's say, because technically you could put it as, I don't know, Christian, what could you put it technically as a modular blockchain, right? Like we're not dependent on the infrastructure we're using, but ZK Sync allows us, and maybe you can explain it in simple language, what it does to the validators and why we need the rollup.
Of course. Yes, it's true that it's hard to say if your layer is a layer 1 or 2, because we are something in the middle or more towards one of the, or the other. By the way, just when you were talking, I fixed an error that I saw, and I'm going to continue executing this to see if everything goes fine. Okay, while I talk. And so, okay, if we could have developed an entire layer 1 and make it like its own blockchain, right? With its own nodes and all what it takes. But in this case, for also to get us really focused on what we wanted to develop, right? All these capabilities on a blockchain that would be able to actually query data from the website and call LLMs. We wanted to focus only on that. So for that reason, we choose something, in this case, some kind of protocol that would allow us to be a blockchain, right? To sequence all the transactions, to be able to have nodes that validate the transactions and that mines them, so to speak, right? This is a proof of stake network, but for the sake of the explanation. So instead of developing the whole layer 1 protocol with all the nodes, validators, and mechanism, we choose to have an underneath layer that allows to sequence the transactions, to order them, to secure them as well, right? And that's why we choose ZK Sync. So in this case, what GenLayer does is the execution environment and the storage of the state of your intelligent contracts, but all the consensus mechanism, all the process, all the interactions between validators, when you send a transaction, when the transaction gets activated and proposed by a leader, and when all the validators cast their votes to say if they agree or not with the leader, all those are transactions sent in the ZK Sync rollup layer, right? And all the consensus mechanisms is embedded there, and it's being executed right there.
Yeah, just to add, and please correct me, Christian, if you keep this window open, these addresses you see are actually validators that are, if you look at GenLayer's consensus mechanism, you have to agree on what the leader proposes, right? So this allows, because we are connected to LLMs, our validators are connected, this allows them to fetch data from the internet. There's many other use cases, but the other validators, as you can see there with the vote, they have to agree or disagree within the equivalence principle. And that's basically what they need somewhere to kind of communicate, like let's say you're humans, 5 humans that have to decide, and then you meet in the courtroom, and ZK Sync would be the courtroom where you meet to commit and reveal your votes if you agree or disagree. I hope this analogy was good enough, but they have to chat somewhere. They have to commit their votes, and that's basically what ZK Sync is doing for us. Plus, I think there's something to say on interoperability as well, because now that we're part of the Elastic Chain network, we are more or less interoperable with all the EVM chains that ZK Sync is supporting. Is that correct, Christian?
Yes, that's going to come in a near future. But yes, that allows us to become more interoperable by default. Yes.
Yeah.
We can also see here all the consensus stuff, right? We can see that the leader processed the transaction first, and it proposed a receipt, right? With its equivalence principle output, which means from that code that was non-deterministic, the output of the leader was, okay, as I have performed this whole task, right? Getting the web content and executing this prompt, and my answer is the score is 1-2, and the winner is team 2. okay, and the status is a success, okay, from this execution. And here we can see that all the validators, they got the leader receipt and they cast their vote as they agree. Okay, they did the same. There is no execution equivalence principle output here because they just executed by themselves. They don't propose anything. They just execute the code by themselves and check against the leader receipt if they agree or not, right? And here you can see all of them. Okay, in this case, since this is a studio, we also have more information here about what was the validator using, the provider and the models and everything in between, right? And just to finish, I mean, there is a lot of information here. Now I'm back.
Yeah, now you're back.
Okay, here we have all the information about the execution. Here there is a little bit of a mix between what is the EVM transaction, what is the generated transaction that gets inside that, right? But if we can, just to finish the example, we can see that right now, if we call again the get bets method, we get that the real score is 1-2, the winner was the team 2, right? And from here, we could distribute some tokens, earn some points, right? And probably in another day, we can get together again and improve this example to include the points or even token distribution or whatever. Yeah.
Definitely, and I just want to add that actually everyone, this is an example of a prediction market. Everyone can try out a prediction market with GenLayer already just for testing purposes on agent.intelligentoracle.com. So the Intelligent Oracle is exactly like, let's call it a white label solution that lets you fetch data from the internet, and you can try it out with agent.intelligentoracle.com, only on the local test version, so it's not on the blockchain, but everyone can easily create a prediction market. And as you've seen, Christian basically created a prediction in 50 minutes. So it's super easy. You can't do it on any other blockchain, natively fetching data from the internet as Christian just did it. That's only on GenLayer. Christian, thank you very much. I think we've answered all the questions. There's actually steam coming from your head because I think you've been cooking too much. You've been cooking too hard.
No, it's a pleasure always to try to explain people these unique things that we are building here and that we are so hyped to be building, right?
Yeah.
So having so much fun and learning so much.
Yeah, you could basically, like, what people don't understand is this is in Python. You could basically create an AI agent. You can do agentic reasoning. You can basically create one here, and as soon as we have mainnet up, it's going to be interoperable across many ecosystems. So basically, you already have everything here. Plus, you don't have to, transfer anything to other ecosystems because you can use it on Solana or on Ethereum or anywhere as well, because those contracts can just call intelligent contracts. So you don't have to code it from ground up, and you can code it in Python. Exactly. How to mint the POAP? I'm going to share this link once again. POAP Home is the app, and then you just type in coding -AI -dApps. That's the secret passphrase option. If you have any other questions, guys, please follow us on Twitter. In our bio, you can find our Twitter and our Discord link. Feel free to join us in the groups. Christian is happy to answer any question any developer of you might have regarding the studio or any coding questions in the dev chat on Discord or also on Telegram. And yeah, feel free to join us on Telegram, join us on Discord. We're having a lot of events there, and we're just ramping up with our community efforts. One of them is going to be the POAP, which we're going to use for future rewards. And yeah, I think we've covered a lot today, Christian. Thank you very much.
Pleasure.
Yeah. Join us on Discord, on Telegram, try out the studio, and see you next time. Thank you, guys. Bye-bye.
Bye-bye.